So this video is now going to introduce some of the methods for evaluating limits. And what I've listed here are the most common ways that we can evaluate limits, and they're pretty much written in the order that most people are going to choose to do this. So the first way you want to try to evaluate a limit is substitution. It's the fastest, easiest way to do one. You just plug in what x is approaching for x and simplify it. But substitution is not always going to work. So then the methods you use after that are kind of depending on how the problem is presented to you. If it's written algebraically, in other words, you see the limit as x approaches a certain value of some function and the function is defined, but substitution for some reason isn't working, you want to go ahead and try to do to simplify that function and then substitute. That's probably the most common way people will do if substitution doesn't work. Second most common way people will choose if substitution doesn't work is what is called L'Hopital's rule. I have an asterisk here because L'Hopital's rule is not always allowed to be used. You have to have a certain situation with a limit in order to be able to use L'Hopital's rule. And for that reason, I'm not going to talk about L'Hopital's rule in this video. It will get its own video at a later time. But let's say then that for some reason substitution doesn't work on a limit, and for whatever reason you can't simplify it, or L'Hopital's rule doesn't apply, or like right now I haven't actually introduced L'Hopital's rule to you. 4 and 5, looking at the graph or looking at a table are your next best options. And these are kind of equal in that they are probably the easiest method of then evaluating the limit, but they do also tend to take a little bit more time, especially if you're using your calculator. And then the final method, and this is kind of the, oh God, I hope I don't ever have to do this method, is what's called the Sandwich Theorem. And that will get its own video as well. So let's take, for example, looking at the limit of x squared minus 4 over x minus 2 as x approaches 2. When I see this limit and if I'm being asked to evaluate it, my first thought is, let's go ahead and just try substitution. Well, if I try to plug in 2 for x, I would get 2 squared minus 4 over 2 minus 2, which would give me 0 over 0. And this is a problem because I'm not allowed to divide by 0. So substitution's not working. So we have different options we can do here. This is a rational function, and it looks like I'm going to be able to simplify this rational function. So I'm going to try simplifying this algebraically and then substitute again. Now, when I do the simplification, I have not actually evaluated the limit yet, so I still need to write the limit as x approaches 2. That must be written every single step until I actually evaluate the limit. Think of this abbreviation and this notation as an operation, like a multiplication sign, or a division sign, or a square root sign. Until you actually do it, it has to be written. So I haven't found the limit yet, so I still need to write the limit as x approaches 2. But then if I factor the x squared minus 4, I can see that I am going to be able to cancel out an x minus 2. So I'll be left with the limit as x approaches 2, because again, I haven't actually evaluated the limit yet, of x plus 2. And now I want to go ahead and try substitution again, because what I've established is that my original limit is equivalent to the limit as x approaches 2 of x plus 2. And so when I do that, when I plug 2 in for x, I get 2 plus 2, which is 4. But let's say that for some reason you're not able to simplify it, but you have your graphing calculator handy. You could go ahead and graph the function. And because you remember your Algebra 2 and pre-calculus so well, you know that this is going to look like the graph of x plus 2 with a hole at an x value of 2. And I can see then, and using trace, that my y value is approaching 4 when the x values are approaching 2. Or again, I could make a table or more easily pull a table up on my calculator And when I look at the table, yes, there's an error when x equals 2, but remember, for a limit, I don't care what happens at 2. I care about what are my y's approaching as I get closer to an x value of 2. And I can see, well, I've got 3.8, 3.9. Coming from above or from the right, I've got 4.3, 4.2, 4.2, 4.1. And it's looking like that limit is approaching 4.